In today's video, we're going to talk about solving linear trigonometric equations in sine and cosine. And at the beginning, I have two sentences on the top, so let's read them together. It says, recall that the period of the cosine, sine, secant, and cosecant functions is 2 pi. The period of the tangent and cotangent functions is pi. So what that means, it just means that for cosine, sine, secant, and cosecant, the graph of these functions repeat itself every 2 pi, by every 2 pi. And then for tangent and cotangent, the graph repeats itself every pi. And let's use example 1 and practice 1 to demonstrate how you're going to use the period to solve the problem. Example 1 says, find all possible exact solutions for the equation cosine of theta is 1/2. As we remember from the unit circle, the cosine is simply the value of the x-coordinate, right? So I recommend that you do a graph for this problem. You will do a coordinate plane and then you do a circle. My circle is not perfect, but it's okay. And then you could label the x and the y's, right? Cosine, if you remember, it's the x-coordinate. And since the x-coordinate is 1/2, you could actually label the two solutions visually. So remember, the unit circle, the radius is 1. So this point represents 1. And then you should be able to figure out 1/2, which is approximately right there. And then this line that I just graphed intersects with the circle at 2 points, right? Let's mark those 2 points. You have this point and you have this point. These 2 points correspond to 2 angle measures that are on the unit circle with the x-coordinate of 1/2, which means the cosine of this angle or these 2 angles will be 1/2. And that's actually the solutions that we can find within the unit circle. And if you look at your unit circle, right, you will be able to know that these 2 angles are positive 60 degrees and negative 60 degrees. Or you could also use the 300 degrees. So look at your unit circle and find these 2 angle measurements. And you should be able to see, I'm going to change the color. You should be able to see that theta has to be either 60 degrees or 300 degrees. This 300 degrees can also be written as negative 60. You can also do negative 60, by the way. And then how do we know which angle to use? It's really up to you. And sometimes the question will give you a range of the angle measurements, saying that the angle has to be between 0 and 360. If that's the case, then your solution will be 60 and 300. But this one is asking all possible exact solutions. So you have to include all of them. How do you include all of them? You have to include all the angles that are also coterminal as these 2. And the recommendation is we're going to do plus minus at the end. And we're going to do k times 360. Same thing with the other solution, plus minus k times 360. So let me elaborate on this, what I just did, right? The k right here belongs to an integer. So for this handout, I'm going to use this notation right here, just saying that my variable k is an integer. And usually there are 1, 2, 3, 4, 5. So the expression that I just write, 60, let's say do the plus k times 360. This could be expanded as 60 plus 0 times 360, right? That would just give you 60. Or you could do 60 plus 1 times 360. That would give you 420. But you could also do 60 plus negative 1 times 360. And that will give you negative 300. So these angles that I have right here, these 3 angles, they are all equivalent to 60 degrees. This is because the period of cosine is 2 pi. And so you could just imagine the same angle, the terminal side rotate another 360 degrees counterclockwise or clockwise, right? It will land on the same line, on the same terminal side. So all these angles are equivalent, and all these angle measures are the solutions. That's why we have this notation, 60 plus minus k times 360. And since we have another solution, 300, so you also need to do that. 300 plus minus k times 360. All right, so that's the solution to example 1. Let's use practice 1 as a practice. Okay, so practice 1, I'm going to do a coordinate plane again. Actually, I should do circle first, but it's okay. So I did a circle, and then you have the coordinate plane. This time is sine. So sine, if you remember the unit circle, it's responding to the y-axis, so the vertical axis, and it's 1/2. So you can do a line right here passing through 1/2 on the y-axis, and it intersects the circle at these 2 points. These two are the solutions. And again, you're going to look at your unit circles. Look at those 2 angle measures that will give you a y-coordinate of 1/2. And according to the unit circle, you will find 2 numbers. The first number is 30 degrees, and the other number is 150 degrees. So I'm just using the numerical degrees. You can use radians as well. If you use radians, actually I'm going to do that for this problem. But for now, let's just do the plus minus. So I'm going to do 30 plus minus k times 360 degrees. And 150 degrees plus minus k times 360 degrees. So this is if you use numerical degrees. And if you use radians, the first one will be pi over 6. That's 30 degrees, right? And then instead of saying plus minus k times 360, we're going to do k times 2 pi, because 2 pi is equivalent to 360 degrees. So same thing with 150. This is equivalent to 5 pi over 6. And then you're going to do plus minus k times 2 pi. Some people might prefer writing k times 2 pi as 2k pi, so it's up to you, whichever way works for you. And that will be practice 1. Example 2, solve the equation exactly. So we have an equation in trig. To solve trig, first identify the trig, right? The trig is right here, which is cosine theta. So you just do inverse operations, which is plus 3 on both sides. And that will give us 2 cosine of theta equals -2. And we're going to divide both sides by 2 to isolate cosine of theta. And we get cosine of theta is -1. And then let's do a visual. This time I'm going to do a circle first, right? So this is the unit circle, and then we have the axes. And because it's cosine, we know it's the x-coordinate. So you're looking at the x-axis. And the x-axis, the value is -1. Because it's a unit circle, the radius is 1. So this point has to be the solution. And then you're going to check out what this angle measure is on the unit circle. Or you could just look at the graph. This one is not that hard to figure out. Your theta would just be 180 degrees. Or you could use radian pi. And do we need to do the plus minus k times 360? The answer is no. So why is that? Is because this question gives us a range. It says that our angle measure is between 0 and 360. 2 pi is equivalent to 360. So that's why 180 is the answer, or pi is the answer. All right, practice 2, we have another trig equation, and this time it's an equation of sine. So I'm going to circle that, and we're going to do inverse operations. First, subtract 1 from both sides. And this gives us 2 sine of x equals -1. And then we divide both sides by 2. And this will give us sine of x is -1/2. And then we're going to do a unit circle sketch. All right, and then do the axes. And remember, sine is the y-coordinate, so we're looking at the vertical axis, and the value is -1/2. So I'm going to do a horizontal line. And this line passes through the unit circle at these 2 points. And these two are the solutions. Again, the solutions are within 0 and 2 pi, right? So that's just the interval notation, saying that the angle has to be between 0 and 2 pi. So the two highlighted on the left and on the right, as you can see, they are equivalent, okay? Just two different ways to write the interval. And because of that, you just use your unit circle or read the angle measurement. The angle measurement, just remember the symbol this time is x, and the two angles are 210 degrees or 330 degrees. And if you use the radian, it's going to be 7 pi over 6 or 11 pi over 6. All right, example 3, solve the equation exactly. This equation is sine, so we're going to do inverse operation, +1 + 1. And this gives us 2 sine squared equals 1. And then we divide both sides by 2. Oops. Divide both sides by 2. We obtain sine squared is 1/2. And we're going to take a square root on both sides. To do the square root property, right, you will get sine of theta is plus minus square root of 1 over 2. And this thing, if you simplify, it's going to be plus minus square root of 2 over 2. And you could use your calculator to estimate how much it is. So this is approximately 0.7. So you could do a sketch, visualize the solutions. Yeah, I forgot to do the circle. Do the circle first and then do the axes, right? So you have this circle, unit circle, and because it's sine, so we have the y-coordinate. That's what we're looking at. And I mentioned that this value, if you use your calculator, it's approximately 0.7. So you have positive 0.7, right, which is right here. And then we have negative 0.7. You just have to estimate what they might be. And that tells us we have 4 solutions, as you can see. So use the unit circle, find these angles. I'm just going to use the numerical degrees, not the radians. So the numerical degrees in this case will be 45 degrees, 135 degrees, 225 degrees, and 315 degrees. And again, this time you're looking at the y-coordinate on the unit circle. You look for positive radical 2 over 2 and negative radical 2 over 2. And those are the 4 angle measures that you will find. And of course, you could use the radians as the solutions as well. Okay, so practice 3, solve this equation exactly. This one is cosecant, right? Cosecant is kind of different because we usually don't use it that much. So I recommend that you're going to change it to a trig function that you are familiar with. By definition, cosecant is the reciprocal of sine. So we're going to rewrite that as 1 over sine of theta equals -2. And then we're going to take a reciprocal on both sides. So that means sine of theta is -1/2. And again, I just took a reciprocal of the equation on both sides. That's how I got sine of theta is -1 over 2. And then let's do a visual. So we have a unit circle, and we're dealing with sine. Sine means you're looking at the y-axis, and the value is -1/2. So do a horizontal line. And we have 2 solutions right here. But this time you do have to pay a little bit attention to the interval. It's not between 0 and 2 pi anymore, like example 3, right? This time it's between 0 and 4 pi, which means you do have to do 1 rotation of 360 to get all the solutions. If you look at the unit circle and you look for the y-coordinate of -1/2, you're going to get 2 angles. They are 210 and 330, right? And then because the angle measurement, we're going to convert it to numerical degrees, because the angle measurement is in between 0 and 720 degrees. 4 times 180 is 720. We have two more solutions. To get the other two, we need to add 360 for each of them. And again, you're using the coterminal angles. So the other one will be 570. The other one is 690. So as you can see, we have 4 solutions in this case. A total of 1, 2, 3, 4. Example 4, solve the equation exactly. This time we have a tangent. So for tangent, you are looking at the ratio of the x-coordinate and the ratio. You're looking at the ratio, right? And in this time, the ratio will be the ratio of the y-coordinate to the x-coordinate, because it's sine over cosine. So again, we're going to do a unit circle right here. And then we're going to look at both of the axes. And this time, the values are not the coordinates. The values are the ratio of the coordinates. So the ratio of the coordinates is 1, which means the x-coordinate and the y-coordinate must be the same. Okay, so x-coordinate equals the y-coordinate. And if you look at the graph, the unit circle, you're gonna find 2 points. These 2 points. It's basically the diagonal of the first and the third quadrant. You're gonna find 2 angle measures whose coordinates are the same. They're identical. And in that case, the tangent will be 1. So that means the angle that we have right here, which is theta minus pi over 2, using the unit circle, it is equal to, I'm going to convert it to numerical degrees, okay? So basically theta minus 90 degrees, right? It's equal to, and then you're going to use the unit circle, find out those two. It's going to be either 45 or 225 degrees. So check out your unit circle. You will be able to see that those 2 angles, the y or coordinate and the x coordinate, they're identical. And that means the ratio of the y to x will be 1, which is the tangent. So that's why we have this equation right here. This equation right here we'll be able to solve. So we have actually 2 equations. The first one is theta minus 90 degrees is 45 degrees. The other one is theta minus 90 degrees is 225 degrees. All right, and then we're going to solve them for theta. So for the first one, we're going to plus 90 on both sides. And this will give us 135 degrees. For the second equation, we're going to plus 90 on both sides. And this will give us 200 and, this will give us 315, right? 315 degrees. All right, and then before you box these 2 answers, double check the range, right? So our theta has to be between 0 and 2 pi, or 0 and 360. And they are, so that means we are okay to box those 2 answers. Okay, practice 4, solve the equation exactly. So we have another tangent equation. So to solve this tangent equation, first we need to distribute on the left hand side. We have this parentheses. So let's distribute. I'm going to get 2 tangent of x plus 6 equals 5 plus tangent of x. And then next, I'm going to move tangent to one side. So I'm going to subtract tangent. This is because the coefficient of tangent is greater on the left-hand side. So I'm going to subtract tangent of x from both sides. And then on the left-hand side, we're going to have 1 tangent of x, right? Plus 6 equals 5. And then we subtract 6 from both sides. And we get tangent of x is -1. So remember, tangent is sine over cosine. So we have another ratio, but this time the ratio is -1, which means the coordinates of the x and y, they must be opposite numbers of each other. And the diagonal this time will be the diagonal of the second and the fourth quadrant. So you could check out your unit circle. You will be able to find out 2 angle measurements whose coordinates are the opposites of each other. Let's write down the angle measurement. By the unit circle, those 2 angles are 135 degrees and 315 degrees. And of course, you could use the radians. Before you box them, let's double check the range. So it says the x has to be between 0 and 360, and we do have that. So I'm gonna circle that. All right, so that's the first page. Let's move on to the second page. Second page, we're gonna solve these equations using calculator. Sometimes unit circle might not be able to help if the values that you're looking for are not on the unit circle, right? So we have these practices. And then on the top, I gave you the range of the 3 main trigonometric functions and their inverses, which we will use in these examples. Just remember that all the inverse functions, like the sine inverse and cosine inverse, tangent inverse on your calculator, they will only give you an angle measurement that are within the range that I have right here. For example, sine inverse, your calculator will always give you a value that's between -90 and +90, but that's not always the case, right? Because sine, as you remember, is a periodic function. So sometimes the angle measurement might be out of the range. So you kind of have to know which angle you're going to use. So let's use example 5 to demonstrate. We're going to use your calculator to solve the equation sine of theta equals 0.8, where theta is in radians. And as you can see, they do want you to write the answer in radians. So you are going to change your calculator settings to radians for this one. So let's first start with writing down the inverse function, right? The sine of theta is 0.8. That means sine inverse of 0.8 is theta. So what we did right here is we basically do the inverse of sine. The inverse of sine is sine inverse, and then you switch these 2 numbers. It's kind of similar to the log and the exponential that we did in early handouts. You do the inverse of the main function and then you switch the numbers. So that's how I got the first equation. And that equation basically gives you the value of theta. You just need to use your calculator to calculate. So on your calculator, you're going to find this sine inverse and then enter the value of the function is 0.8 and then hit enter. Just make sure that your calculator is set to use radians as the angle unit. On your calculator, we're going to get this value. So theta is approximately 0.9273. So that's one answer. And because we need to find all solutions, so we need to add plus minus k times 2 pi, right? Remember from the first page, I use 2 pi is because they want the theta to be in radians. But this is not the solutions, the complete solution. There is one more solution. So how do you know that, right? That's where the visualization will help. So we're going to do a unit circle. And then I'm going to do my axes. And then check out this equation. Sine of theta is 0.8. And then visualize the solution. Sine of theta, meaning that we're looking at the y coordinate, right? So y coordinate. And then the value is 0.8, so you just kind of have to estimate what they are. So it will be these two. We have these two. Oops. We have these two solutions. Ooh. So one is here and the other one is here. And then because the value 0.8 is not on the unit circle, that's why we cannot use the unit circle to figure out the angle measurement exactly, but we are able to identify how many solutions are there. So we find out one solution, which is the 0.9273. You could convert it to a numerical degree if you want, which is this angle right here. So that's the angle. And then there's another angle measurement, as you can see on this graph, which is this one. So for this one, if you look at the unit circle, they are symmetric in terms of the y-axis, and the relation between them, they're actually supplementary, meaning that they add up to 180 degrees. So you could actually look at two angles on the unit circle that are symmetric, and then you'll be able to see that they do add up to 180 degrees. So that means the second solution, I'm going to add a subscript right here, say this is my theta 1. The second solution, theta 2, has to be pi minus theta 1. This is because they are supplementary, they add up to 180 degrees. So you're going to use your calculator and calculate pi minus 0.9273 and see what that is. And then for the final answer, we're going to do plus minus. So if you calculate that, it's going to be approximately 2.2143. And then we're going to do plus minus k times 2 pi at the end. And essentially, we have two solutions. And as you know, the calculator will only give you one of them. In order to find all solutions, a visual is needed, and it will help you find the other. Okay, practice 5. Practice 5 is secant. Secant theta is -4. And again, secant is not something that we are familiar with that much. So we're going to use the reciprocal definition. Secant is the reciprocal of cosine. So I'm going to rewrite the equation. 1 over cosine of theta is -4. And then you take a reciprocal of this equation on both sides. You get cosine of theta is -1 over 4. Let's visualize this. So we're going to have a unit circle and then axes. Cosine is the x coordinate. So we're going to look at the x coordinate. The number is -1 over 4, which is -0.25, right? So it's going to be pretty close to the y-axis, and that means we have these two solutions. So let's use your calculator. On your calculator, you're going to first convert this to the inverse, right? So cosine becomes cosine inverse, and then you switch these two numbers. So cosine inverse of -1 over 4 equals theta. And use your calculator, you're going to get one of the solution. I'm going to call it theta 1. It's cosine inverse of -1 over 4. And that will give you approximately 1.8235. 1.8235. And don't forget that we need to add plus minus at the end. So plus minus k times 2 pi. And this is one of the solutions. And you might wonder which solution they gave you, right? So check out the hint that I have right here. For the cosine inverse, your calculator will always give you an angle that's in between 0 and 180, which means it's in the first two quadrants. And this is the angle that your calculator gives you. Let's highlight that. So it's this pink one. That's the angle that your calculator gives you. And we have another one. So the other one, which is the orange one right here, you have to use a relation. So what's the relation that you can find? You could use your unit circle and find two angles that are in the second and third quadrant. They have the same x coordinate. you will be able to see that the relation between those kind of angles, they add up to 360. So as a result, the other angle that we can find will be 2 pi minus theta 1. So on your calculator, you're going to calculate 2 pi minus 1.8235, find out what that is. So it's approximately 4.4597. And then you're going to do plus minus k times 2 pi. And then let's highlight these two solutions. So that's one of them, and this is the other one. So there is another way to do this one. I just want to point it right here. So these two angles, they're actually the opposites. So you can kind of imagine, I'm going to do it. This is the initial side, right? And if I do counterclockwise, I reach this pink terminal side. If I do clockwise, I reach this orange terminal side. But it's the same degrees as you can see visually because it's symmetric across the x-axis. So another way to write your theta 2 is theta 2 is simply the opposite of theta 1. It's just rotating a different direction. So that's why this is probably easier. You simply do negative 1.8235, right? Plus minus k times 2 pi. So this is the alternative way of writing the other solution for this case. All right. Moving on to the last section of today's lecture, solving trigonometric equation in quadratic form. A lot of the equation that you might see, they look trigonometric, but they are quadratic equations in disguise. Let's use example 6 to illustrate. It's 2 cosine squared minus 3 cosine plus 1 equals 0. So why don't we just do a substitution? I do see cosine a lot, right, in multiple spots. So we could do a simple substitution. Let's say I'm going to say cosine of theta is x. And then I'm going to rewrite the equation, right? So that means 2 cosine squared becomes 2x squared minus 3 cosine of theta becomes minus 3x plus 1 equals 0. And as you can see, this is a quadratic equation. For quadratic equation, you can solve it by factoring, completing the square, or quadratic formula. I'm going to factor this. So I'm going to try factoring. First, guessing 2x squared. 2x squared comes from 2x and x. 2x times x give you 2x squared. And then for the positive one, I noticed that the middle term is negative and the product is positive 1. So there's only one way that you can do, which is negative 1, right? And then you could double check, see if it's right. So I'm going to do a double chain. You get negative 2x, negative x. And if I add them, I get negative 3x. And that is what we have in the middle. So this is the correct way to factor it. And then by the zero product property, each of these two factors is 0. So we get two equations. You solve each of them for x. You're going to get x is 1/2 or x is 1. Just remember, this is not the final answer because we did a substitution at the beginning right here. So we have to substitute back. That means cosine of theta is 1/2 or cosine of theta is 1. Let's do a graph for each of them. First, cosine of theta is 1/2. So we have a unit circle, axis, and because it's cosine, we're looking at the x-coordinate. The value is 1/2. So we have two solutions right here. It is a common value, which means you are able to find the solution from the unit circle. So from the unit circle, we will find out the two angles are 60 degrees and 300 degrees. Notice that I did not use negative 60 because the question did give us a range of theta. It has to be between 0 and 360. So that's why those are the two. And then for the second equation, we're going to do another unit circle. And the x-coordinate this time is 1, which means it has to be right here because the radius of the unit circle is 1. And we just have one solution right here. And that is either 0 degree or 360 degree. We don't do 360 because the restriction is 0 less than or equal to theta less than 360 degrees, which means you cannot be 360, but we are able to say 0. So theta could also be 0 degrees. And we have three solutions right here: 60 degrees, 300 degrees, and 0 degrees. Practice 6. Let's solve this. So this one we have sine. I'm going to do a substitution. So let sine theta be x. And then we're going to substitute this into the equation. 2x squared minus 5x plus 3 equals 0. Similarly, I'm going to factor the left-hand side. 2x squared comes from 2x times x. For the 3, since the middle is negative, it has to be -3 and -1. I'm going to give a guess. I'm going to put -3 here, -1 here. If it doesn't work, I'm going to switch the two numbers. Let's see if this works. I'm going to do a double chain. 2x times -1, -2x. -3 times x, -3x. And if I add them, I get -5x, and that is what's in the middle. So this is the right way to factor it. And by the zero product property, each of them could be 0. 2x minus 3 is 0, or x minus 1 is 0. Solve each of them for x. X could be 3 over 2, or x could be 1. And for this one, we're going to eliminate 3 over 2. Why is that? Is because what is x? X is sine of theta, right? Sine of theta cannot be greater than 1. So the range that I have on the top, you could see right here, for a sine function, the value has to be between -1 and +1. It's the amplitude of the sine function. So x cannot be 3 over 2. But x can be 1. It's the maximum value. So sine of theta could be 1. And then you could do a unit circle. You can also see it from the unit circle, right? The unit circle, the radius is 1. So the value of your sine or cosine cannot exceed 1 or go below -1. And if you're looking at sine, we're looking at the y coordinate. So we're going to do a horizontal line. It has to be right here. No other way. I didn't do a good job, but I'm going to redo it. So it has to be like this. And that means there's just one point right here. That's the solution. And that angle is pretty easy to identify, right? It's the 90 degrees angle. And then before you box it, just double check the restriction. Our angle has to be between 0 and 360. So this is totally fine. We just have 90 degrees as the angle. You can also do pi over 2 if you write it in radians. All right, final practice problem, practice 7. This is 2 cosine x sine x plus radical 3 sine x equals 0, and the x is between 0 and 360, including 0 but not 360 degrees. So for this one, there is a hint. It talks about factoring. Do we do substitution? I would say it is possible that you could solve it by substitution, but for this one, we simply factor it. First, I noticed that both of these two terms have sine of x, which means we can factor out. So I'm going to factor out sine of x and then write down what's left. For the first one, if I take out sine of x, I have 2 cosine of x left. Plus, for the second one, if I take out sine x, I have radical 3 left. So this will be what happens after I take out sine of x, and this is equal to 0. And notice that this is a 0 product because we have something multiplied by something equals 0. It's a 0 product. By the 0 product property, each of the factors could be 0. Sine of x could be 0. Or the second factor, 2 cosine of x plus radical 3 is 0. If it's sine of x, you could do a little graph right here, right? You have a unit circle, and we're looking at the y-axis because it's sine, and it's 0. So it's basically the x-axis. That's the line. It intersects the circle at these 2 points. And that means we have 2 angles. x is 0 degrees or 180 degrees. Again, you could use radians if you want. For the second equation, we're going to do inverse operation, subtract radical 3 from both sides. And we obtain 2 cosine of x is negative radical 3. And then we divide both sides by 2. Cosine of x is negative radical 3 over 2. And you could use your calculator and calculate what this is approximately. I think it's approximately 0.8 something, 0.87, 0.85. So what you do is you do a unit circle, right? Visualize the solution. This one is about cosine, so you're looking at the x coordinate, and as I mentioned before, it's approximately negative 0.8, so somewhere here. And that means we have two solutions. And this is a common value, so you are able to find it out on the unit circle. So look at your unit circle, look for x coordinates of negative radical 3 over 2 in the second and third quadrant. And the angles are 150 and 210 degrees. And then before you box these answers, double check the restrictions. It says the angle measurements are between 0 and 2 pi or 0 and 360. So we can safely box these 4 angles. That will be the solutions. So this is the handout. Thanks for watching.